notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. Section 1, number theory and computation. All 33 of those videos have been published on YouTube in their entirety. Section 2, consumer arithmetic. All 12 of those videos have been published on YouTube in their entirety. Section 3, sets. All 6 of these videos have been published on YouTube in their entirety. That adds up to 51 videos. Please make use of all of these. We are now at section 4, measurement. This is the 4th of 16 videos. I'm somewhat behind schedule. Then January 2025, by the end of January 2025, statistics, section 5. February 2025, algebra. March 2025, relations, functions, and graphs. April 2025, geometry and trigonometry. And finally, by May 2025, mid-May, vectors and matrices, and hopefully, by then, all of the objectives in this syllabus would have been covered, hopefully. Just a reminder that I have divided section 1 into 33 videos. And as I just said, they are all published on YouTube in their entirety. And that is because this section forms the foundation on which the rest of the syllabus is based. This section here. Make sure you look at these 33 videos and know them well if you intend to continue with the syllabus. Reminder also that you need to know the times tables 2 to 12. If you already don't know it as yet, please make sure you learn them, especially since calculators are not allowed in paper 1. From section 2, all 12 videos, as I said, have been published on YouTube. From section 3, all 6 videos have been published on YouTube in their entirety. We are now at section 4. This first video here has been completed and published on YouTube in its entirety. The next 2 videos, this one and this, they are completed but only partially published on YouTube. And we are now here at objective 3, which has been split into 2 videos, A, which is video 4, and B, which is video 5. Now this is a print screen of the syllabus. We are here, objective 3. Determine the perimeter of a plane shape. And then in this section, we have 5 more objectives here. And then another 6 more, which gives a total of 15 objectives. Section 4, 15 objectives on measurement. So as I said, we are here, objective 3. We do have some explanatory notes, which says estimating and measuring the perimeter of compound and irregular shapes, and also calculating the perimeter of regular polygons and circles. So we need to split this objective into 2 presentations, 2 videos. In video 1, we will deal with what we mean by perimeter, and then we will learn how to calculate the perimeter of regular polygons and circles. And then in video 2, we will estimate and measure the perimeter of compound and irregular shapes. So what is the perimeter of a plane shape? Now, if you look at some of these plane shapes, one here, we have a rectangle. The perimeter is a math concept that measures the total length round the outside of a shape. So if you begin at A here and you go in a clockwise direction to the right here to this point and then come down here and then go across here and then go up back there, that is the perimeter of the rectangle, is the distance around it. If you take a circle like this, figure 2, if you begin at any point here and go in a clockwise direction or an anti-clockwise direction like that, keeping on the edge of the circle, you go all the way around and come back to this point. That is a perimeter of that shape. If you take a six-sided shape like this, and you begin at any point, let us begin at C, you go up to that point, come across to the right here, come down here, go down there, and then come across here and go up back to where you began. If you were to measure that distance, that will be the perimeter, the distance around. If you take this shape here, figure 4, and you start at any point, let's begin at D. If you go to the right and then come down here and come across here and up there and then come back here and then up here and then go across like that, up there, around like that, up like this to that point and come down back to where you began. If you were to measure that distance all the way around that shape, that would be the perimeter. If you take this shape here, begin at any point, let us say we begin here, go in any direction, either up or below, go all the way around, and come back to where you began, and you measure that distance. That is the perimeter, is the distance around a shape. If you look at this irregular shape here, let's say we begin at F and we go to the right that way, this way, come down here, come across here, go like that, like this, come up here, like that, go back to the right, up like this, and we come back to F. If we were to measure that distance or calculate it, that will be the perimeter of this shape. So we know what perimeter means. So what is a polygon? Most mathematics books and teachers will tell you that it is a two-dimensional closed shape made up of 3 or more finite number of straight line sides. Not so fast. Some mathematicians will argue that we need to leave out this finite number out and just say that it is a closed shape made up of 3 or more straight line sides. Now, according to this other definition, a circle is a regular polygon with an infinite number of straight line sides, because if you take a circle and you divide the circumference into, let's say, 1 billion pieces, then each of the little pieces becomes a straight line. However, we will work with this one. Even though technically a circle can be considered a regular polygon with an infinite number of sides. So let's look at polygons, leaving out the circle. So first of all, triangles. You have isosceles triangles, and in isosceles triangles, you have equilateral triangles, and then you also have out here scalene triangles. They are all triangles, they are all polygons. Then you have quadrilateral, four-sided figures. You have parallelograms, which include a rectangle, which also include the square. And then you have the rhombus, which is a special kind of parallelogram. You have trapezium, and you have the kite. All of those are quadrilateral. They are all polygons. Then you have other regular polygons with 5 or more sides. Example, pentagon, the hexagon, the octagon, and so on. And then, of course, you have irregular polygons with 3 or more sides. So those are all polygons. And this slide here you see is from section 8, which deals with geometry and trigonometry as it relates to construction of polygons. But that is section 8. We will come to that. We are now at section 4. So regular polygons. Example 1. The rectangle shown at right has a length of 8.2 meters and a width or breadth of 3.5 meters. Calculate its perimeter. So this is the rectangle. We can see 2 sides. We know that in a rectangle, opposite sides are equal and parallel to each other. So how do we find the distance around this? Well, the perimeter of a rectangle is equal to length times breadth multiplied by 2. So this is the length, this is the breadth. We will add those two and then multiply by 2, and we get 23.4 meters. Now, this answer has 3 significant figures. We need to round it off at 1 decimal place, which is the same thing in this case. So just to show that we are rounding off here, and that 4 is our uncertain digit, we add plus or minus 0.05 meter. Example 2. Each side of the regular pentagon shown at right has a length of 65 centimeters. Calculate its perimeter in meter. So this is a regular pentagon, meaning that all sides are equal. If you know that this one side is 65 centimeters, you want to find the distance around. In meters, you will carry this 65 centimeters to meters and you will multiply by 5, or you will add 0.65 5 times. So the perimeter of a regular pentagon is 5 times the side. We know the side is 65 centimeters, which is 0.65 meter. You multiply that and you get 3.25 meters. Now, this answer has 3 significant figures. We need to round it off to 2 decimal places. So there is no need to make any adjustment because this 3 significant figures has 2 decimal places. So just to show that we are rounding off at this point, at the 100 position, we add this piece plus or minus 0.00. Those 2 zeros are for these 2 digits, and then you add a 5 here. Now, just to make sure you understand that, the highest position that we have an uncertain digit is this 100 position. And so recall that for addition and subtraction, you round off at the highest position with an uncertain digit. In this case, all of them have the uncertain digit in the same position. So we round off at this 5, which is 3 decimal places, which doesn't really matter in this case. What matters is that that is the highest position with an uncertain digit. Now, if this were an irregular pentagon, you will be given all the sides, and then to find the perimeter, you just add them all together. If you find this video useful and interesting, please like and share. That is, like and share. You may also consider subscribing to this channel. Example 3. Each side of the regular hexagon shown at right has a length of 4.3 meters. Calculate its perimeter. So this is the hexagon. It's regular, meaning that all the sides are equal to each other and all the angles are equal to each other. This one side down here is 4.3 meters. So you add 4.3 6 times, or you multiply 4.3 by 6. So the perimeter of a regular hexagon is 6 times its side, 6 times its side. So that will, and since one side is 4.3 meter, you multiply that by 6 and you get 25.8 meters. Now, I know you may look at this and say, well, I only have 2 significant figures here, and down here I have 3 significant figures, so I must round it off to 2 significant figures. But remember, this 6 here, you are adding that number 6 times, so that our uncertain digit in the highest position is there in the 1/10 position. So in this case, it isn't the number of significant figures. It is the highest position that has an uncertain digit, which is a 1/10 position. So you round off at the 1/10 position. And to show that you round off there, you add plus or minus 0.05 meter, because half of this 1/10 position is 500. Now, if this were an irregular hexagon, you would be given all the sides. To find the perimeter, just add them all together. And you follow this pattern for all regular polygons. Now, let's deal with the circle. The perimeter of a circle is actually called the circumference. It's the distance around. Now, the circle can be thought of as a regular polygon with a very large number, maybe an infinite number of sides, and each side being very, very small. If you divide this circumference in, let's say, 1 billion sides, then each side would be extremely small, and each side is in essence a straight line. So we can think of this circle as a regular polygon with a large number of sides, and each side is essentially straight. Now, if we know the number of sides and the length of one of those sides, we can multiply them as we were doing with the other polygons, and we will get a very close approximation, now note that, of its circumference and perimeter. There is an easier method if you are given just the diameter or the radius of the circle. Now, this is the method required by CSEC, and they give you a formula for that that will be on the formula sheet. You don't have to memorize this. The circumference of a circle is equal to 2 pi r. Of course, r is the radius. So if we know the radius of this circle from here to there, we will multiply 2 and r and pi, and we will get the distance around. Or if we know the diameter, we will just multiply the diameter by pi. So let us say the diameter is 28. Then of course the radius will be 40. So we can easily find the circumference of this circle. Now the diameter of a circle shown at right is 28 meters. Calculate its circumference. So this is the circle. This is the diameter from over here to over there. The diameter is 28 meters. So if the diameter is 28 meters, then the radius will be half of that, to be 14 meters. So CSEC will give you a formula sheet that says circumference of a circle is 2 pi r, and it even explains what r is. So circumference is 2 pi r, or you can also use circumference is equal to pi d, because if you multiply 2 by r, you will get the diameter. Either one is correct. Circumference is equal to 2 pi d, multiply pi by the diameter, and you get 22 over 7 times 28, and that gives you 88 meters. Just to show that you are rounding off at this ones position, you write in here plus or minus 0.5 meter. The answer has the correct number of significant figures. You can stop there. So that this part here is not really required, but to be on the safe side, you can always add plus or minus 0.5 meter to show that you really know what you are doing. Now, the radius of a crop circle irrigation system is 105 meters. See picture at right. calculate its circumference. Now, in areas where rainfall is scarce, water is drawn from a river, and from the center here, you have pipes going outwards, and that pipe rotates around here, and as it rotates, water is pumped through it so that this part of the land is irrigated and you can grow plants. So we have a crop circle here. Now, this is not the mysterious crop circles that appear in certain parts of the world. These are crop circles made by irrigation. So we want to calculate the circumference of this crop circle, knowing that this radius is 105 meters. Well, CSEC gives us a formula that says circumference is equal to 2 pi. Circumference is equal to 2 pi r. That is the perimeter of the circle, which is called the circumference. You can also use pi d. So circumference is equal to 2 pi r. R is 105 meters. Circumference is equal to 2 times pi times 105. You work that out and you get 660 meters. That is to say, if you start walking here, you go all the way around in a clockwise direction, all the way around, inspecting this crop circle. If you are working on this farm and you come back here, you would have walked a distance of 660 meters. Now, you can leave it like that, and hopefully CSEC will accept that. But just to make sure that you know where you are rounding off at the ones position. And so you add plus or minus 0.5. Your answer must have 3 significant figures. So this 0 here is the uncertain digit. So as I said, that 660 technically has only 2 significant figures. To show that it has 3 significant figures, you add this plus or minus 0.5 meter. So we just did part of this objective, objective 3. Determine the perimeter of a plane shape. And we did the easier part of this objective, calculating the perimeter of regular polygons and circles. So in this presentation, we just did this part of the objective, calculating the perimeter of regular polygons and circles. That is the easier part. In the next video, we will deal with the next part that says estimating and measuring the perimeter of compound and irregular shapes. And that brings us to the end of video 4 based on objective 3 in section 4.